Well, this video is for Math 111, section 2.4 in the textbook on rational inequalities. So the word rational refers to a ratio or a fraction, okay? And you'll see that most of these problems involve a fraction of some kind. So the first example I give on page 101 is 2 over x minus 3 greater than 0. So before we take a look at this graph and start talking about this, let's review a little bit what we had talked about in section 2.3. Those were polynomial inequalities, and they frequently looked something like this, okay? And the idea was that we found these points where y was equal to 0, and then we were interested in where is y greater than 0, here and here, and where is y less than 0, there and there, okay? And the important part of these roots that we were finding is because that's the dividing line between where y is negative and where y is positive. And that's why we needed to know those values, is because those are the dividing lines. And so to the left of that root right there, y is negative, and so on. Okay? So these rational inequalities introduce another possibility. And so let's look at a graph. Let's look at the graph of this first example right here, 2 over x minus 3. We're going to look for where is it greater than 0. And so I'll show you what it looks like on the calculator in just a minute. So we run into this idea of what are called asymptotes. And these are places where the function or the graph is not defined. The y value is not defined. And that's going to happen on this graph where x is equal to 3. Why? Well, because when x is 3, you get a 0 denominator, okay? And with a 0 denominator in our number system, we can't calculate a value for y, right? If x is equal to 1 here, where x is equal to 1, then y is going to end up being negative 1, right? You put the 1 in for x, and that's 2 over negative 2, and that gives you y as negative 1. So when x is 1, y is equal to negative 1. So that's going to be a point on the graph. But when you get out to 3, when x is 3, we can't calculate a value for y. And so what this graph ends up looking like is something along these lines. And then on the other side of that asymptote, we get something that looks like this. Okay? So let me show you what it looks like on the calculator. And then I'll say something about the different kinds of calculators that we have here. So there's the calculator. Let's get the focus on there. So there's what it looks like on the calculator. Now you notice the dotted line that I drew on the board is not on the calculator. Okay? So there's the dotted line on the board. You notice it doesn't show up on the calculator. If you have one of the older calculators that have the black plastic case, you will see a line where those asymptotes are. Okay? The newer ones, they've taken that out. It doesn't make a whole lot of difference. You should still be able to see that gap, and you can also know where that should be, because that's going to be where the denominator is 0. Okay, so to answer the question, where is y greater than 0, right? Because we're graphing this expression as y. So this question is asking us, where is y greater than 0? Well, that's going to be up here, okay? What x values make that happen? All the x's greater than 3 will make y greater than 0. All the x's less than 3 make y less than 0. We don't have to worry about that because the question doesn't ask us. Okay? All right. So there's the first example. And so the idea here is that we're still going to be interested in roots, Notice this graph doesn't have any roots. It's never actually equal to 0. And I'll talk more about that as we go through these examples. Okay? All right, so let's look at the next example. And let's see. This one is over on page 102. And I've changed it now so that we have x minus 2 on top and x minus 3 on the bottom. And so let me sketch a graph of what that's going to look like. Let's see here. We've still got the asymptote where x is equal to 3. Okay? So I'll put a dotted line in there. And then we've got something that looks like this. And then something that looks like this. Okay? And let me show you what it looks like on the calculator. So there it is on the calculator. You can see there's that gap where x is equal to 3. And then we're also seeing a root at x equals 2. Okay? So, here's the thing. When we were doing the polynomial inequalities, we were only interested in the roots because those didn't have any asymptotes. All right? Now, something like this, the roots are going to be where the numerator is equal to 0. That's at x equals 2. Okay, and we see that on the graph. There's our root at x equals 2. The asymptotes, in this case there's only 1, that's where the denominator is equal to 0, in this case at x equals 3. So now we've got those points identified, and those points are important because that's where y switches from being positive to being negative, or from being negative to being positive. Okay? And that's the only way for a graph to switch the y values from positive to negative, or vice versa. So that's why we want to identify the roots, identify the asymptotes, and then we can go in and look and see, oh, well, where is y greater than 0? Up here, y is greater than 0. Down here, y is greater than 0. There's this little region in here where y is less than 0, but the problem doesn't ask us about that. So the answer to this question is x greater than 3, or x less than 2. Any of these x values will make y greater than 0. Okay? All right, so that's the second example. Now the third example that we use here, let's see. Let's erase this stuff. The third example changes this. So now we've got an x squared minus 2 on the top and an x minus 3 on the bottom. So let's draw a sketch on the board for what that looks like. We've still got the asymptote here at x equals 3. And let's see, now on the graph here, let me show you what I've got in the standard window. We don't see anything out past 3. Well, one thing that you can do is if you hit second graph, that'll bring up the table. Okay, and we can look and see what's going on out past 3. Oh, see those values? When x is 4, y is 14. When x is 5, y is 11.5. So if I go in and I change the window here so that my y, that's the wrong one. There we go, window. We want the y maximum. I'm going to change that from 10 to 15. And then if I go back to the graph, there's the other part of the graph. Okay, so let's go. I'll go put that back on the board. Okay. So we've got this little hooked piece up here, and then down here we've got something that looks a little bit like that. Okay? So, we know that there's an asymptote at x equals 3 because, again, that's where the denominator is equal to 0. The roots are going to come where the numerator is equal to 0. Now you can still use your calculator, that root finding that we did in section 2.3. You can use that to find these 2 points if you'd like. And so let me show you how that works. Again, just review that idea. So this is that process where you hit second and then trace, and then choice number 2 is find the 0, and then we've got to go in and set our left bound and the right bound, and there it is, 1.414, and then if we do that for the other root, set a left bound and set a right bound. That's negative 1.414. So where are those values coming from? Well, if you use this equation right here, you can run this through the quadratic if you'd like to. Right? Here, A is 1, B is 0, C is negative 2. And if you run that through your quadratic program, you should get solutions of x is approximately plus or minus 1.414. So there's positive 1.414, negative 1.414. Now you can also move that 2 to the other side. X squared equals 2. And then if you square root both sides, that's fine, but you have to be careful to remember to take both the positive and negative square roots of 2. That's why we've got 2 roots here. Okay? All right. So that is the first step in doing a problem like this, is to identify the roots, identify any asymptotes. Now we've got all those critical values identified. Now we can answer the question, where is y greater than 0? Well, that's happening up here. Y is greater than 0. And over here, y is greater than 0. So our answer here would be x greater than 3, or x less than 1.414, but greater than negative 1.414. And there's our answer. Okay? All right. One more example, and then we'll look at a few problems. Let's see. Our last example starts over on page 103. So let's get everything ready for that. And that one has an x minus 2 on top, and then x squared minus 3 on the bottom. Okay. So again, the asymptote now is going to be where the denominator equals 0, and the root is going to be where the numerator is equal to 0. And let's look at that one on the calculator. Okay, let's see here. So now this one, we've got 2 asymptotes. It's not immediately clear exactly what the values are going to be for those. Let's see here. Okay, so we've got this kind of happening over there. And then in between the 2 asymptotes, we've got something that looks like that. And then over on the other side, we've got something that looks like that. So here, let me show you what that looks like on the calculator. And so that's what we're looking at there, okay? And you can see that those asymptotes are not marked, right? And the calculator doesn't have any functions that will necessarily go in and tell us where those asymptotes are. So what we need to do is solve this equation. Right? And you can do this the same way we solved the root equation for the previous example. You can run this through the quadratic with a equal to 1, b equal to 0, and c equal to the negative 3. Or you can solve the equation like this by square rooting both sides. But remember that you need to take the positive and negative square roots of 3. I think it's 1.732. Let me double check that. Square root 3 plus or minus 1.732. So that's where those asymptotes are. This is positive 1.732. This is negative 1.732. And then the root itself is actually pretty hard to see on the calculator. It's not really clear. On the calculator, when I held it up to the camera, you could see this line is just kind of sliding right along here. But this root is at x equals 2. And that's part of the reason why the resolution on the calculator is not so great. When you get an asymptote and a root right next to each other like that, the calculator often has trouble showing that. Okay? But now we've got the root and the asymptotes identified, and we can look at this and answer the question. So we can see y is greater than 0 here, and it looks like y is greater than 0 here. There's a couple things you can do to double check that. Okay? One thing that you can do is, again, look in the table. See what it has to say about the y values. So if you hit second graph, that'll bring up the table again. And you can see where x is 2, y is 0. And then you can see all those positive values for y, where x is 3, y is positive, where x is 4, y is positive. Okay? So that matches up with my sketch. It's a little bit hard to see on the actual graph itself, but if you look in the table, you can see these y values are greater than 0. Now the other thing that you can do, besides looking in the table, and this is sometimes helpful, is if you zoom in on that section that we're interested in. So that zoom button is that middle one right there. And I'm going to make a zoom box, choice number 1 there. And we need to go over. So this is going to set a corner for the box. Okay? And then I hit enter when I've got one corner set up. And then if I move over and up, you can see that box opening up like that. And then when I hit enter, that's going to be the new window. There's the root at 2, and then you can see the positive y's there to the right of 2. Okay? And then we go back to the standard window. Okay? So, it can sometimes get challenging to see exactly where's the y positive, where's the y negative, but you've got those two options available to you, looking in the table and zooming in on the graph to see what's really going on. Okay? All right. So now we've got all our information. We can answer the question, where is y positive? So, x greater than 2, or this region in here, x less than 1.732, but greater than negative 1.732. Okay? Now, you might wonder, well, what about this? What's happening over here? How do we know that this doesn't cross over? How do we know that this is not crossing over and making the y's positive again? Well, that's why we do this. It's because the only way for that to happen is if there was another root here, or if there was another asymptote there. Okay, that's the only way for the y values to switch from being negative to being positive, is if they pass through a root or if they jump over an asymptote. And we've already identified all the roots and asymptotes, so we know that there's nothing more going on out in that direction. So this right here is going to be our answer, x greater than 2, or x less than 1.732, but greater than negative 1.732. That's that region in there. Okay, so there are the examples. Those are the ideas that we're going to use to answer these questions. So let's go over to page 107 and take a look at some problems. Okay, so we'll start with problem 2. On page 107, problem 2 says 2x plus 3 over x squared minus 2x minus 35, and we want to know where is that less than 0. And it's important to pay attention to this and to know which one you're working with, whether it's a greater than 0 or less than 0. Okay? All right, so let's look at the graph for this one. Let's see here. 2x plus 3 on the top, x squared minus 2x minus 35 on the bottom. And I'll draw a sketch up here, and then I'll show you what it looks like on the calculator. So it looks like we've got two asymptotes. One is out here. Let's see, the other one is over here. And then the graph is kind of doing this. And then something like that. And then this over here. Okay? So there's the sketch. Show you what it looks like on the calculator. So there's what I'm seeing on the calculator. So now we want to go in and identify where are those asymptotes and is there a root in there somewhere? Okay, so remember the roots are where the numerator is equal to 0 and the asymptotes is where the denominator is equal to 0. Okay, this one is easy, right? 2x equals negative 3, x is negative 3 over 2, or negative 1.5. And you can also use that root finder on the calculator, right, that we were using for the polynomial graphs. You can use that to go in and find this point, but this one is easy enough just to solve for ourselves. Now this one, the asymptotes, where the asymptotes equal to 0. So this is a quadratic, so we should run it through the quadratic formula. And this is where it's really helpful to have a quadratic formula program on your calculator. So a is 1, b is negative 2, c is negative 35. And this is a factorable, right? This quadratic equation right here is factorable. You don't have to do that, but if it is factorable, then you'll often get whole number answers, okay? And so this is going to be 7 out here, and this is going to be negative 5 over here. And let's see, so here's the graph again. And because those are whole numbers, if we go into the table, you can see where x is equal to 7, y, it just says error, okay? And that's because there's an asymptote there. We don't have a defined value for y. And then where x is negative 5, you also get an error for y. And so that's an indication of where the asymptotes are, but really you'll only see that if these are whole numbers. And they won't all be whole numbers, okay? I've set a couple of these up so that some of them, the asymptotes are whole numbers and you can see them in the table and so on. But for other ones, you won't be able to see that in the table. Okay, but now we've identified the two asymptotes and the one root, and the problem is asking us, where is y less than 0? So, over here, y is less than 0. Over here, y is less than 0. So, the answer to our question is x less than negative 5, right? That's this region out here. And then this region in here, between 7 and negative 1.5. So, or x less than 7, but greater than negative 1.5. And so there's our answer. Those are the x values that make y negative. And again, you know, how do you know that this isn't going to cross over again and become negative? Well, if it did, you'd have to have another root or another asymptote, and we've already found them all. Okay? So, that's it for number 2. Let's see here. look at number 4. See, I'll keep those. So number 4, we start out on top, 2x squared minus x minus 3 on top, and x squared plus 10x plus 16 on the bottom. And this one is asking, where is y greater than 0? Okay, so let's go ahead and put that in the calculator. 2x squared minus x minus 3 on top, x squared plus 10x plus 16 on the bottom. And then I'll draw a sketch and show you what it looks like on the calculator. Okay, so it looks like we've got an asymptote right here. Let's see, let me make sure I entered that correctly. Okay. So we've got an asymptote right here, and then the graph is doing this, and we don't see anything going on out here. So that's something we might want to think about looking in the table somewhere along the line. Let's see, the graph comes down like this, and then kind of goes over in this direction, and then we've got this piece right here, but I feel like we're not seeing everything that's going on this graph. So let's think about this a little bit more and see what else we can find. So what I like to do is to solve these equations, because that tells me where to look. Okay? I mean, you can just start poking around on the graph if you want to, but I like to know where are these critical values first, and then that'll tell me where to look for things. Okay, so our roots are at positive 1.5, oops, and negative 1. Okay, so that says that this is going to be negative 1, and this is positive 1.5. That's really helpful. Now let's run the denominator through the quadratic, and this is saying we've got asymptotes at negative 2 and negative 8. So this is clearly negative 2 right here. But, so this is what I was saying about solving these equations can tell you more about what's going on here. So if you had one of those older calculators, right, that has the black case, then you would probably see that asymptote at negative 8. Okay, on these newer calculators we're not seeing it. That doesn't mean that it's not there. So we'll dig into this a little bit and see where the rest of the graph is, okay? Looks like we've got this piece identified, but then out past negative 8, we're not really sure where it is. So let's see here. So here's the graph on the calculator. You can see that one asymptote. You can kind of see those roots in there, but they're a little bit hard to see. But now let's go into the table. And let's see, are we far enough out? We got to go back a little bit more here. And let's get some better focus. There we go. And you can see at negative 2 and negative 8, you've got those error messages. And then the reason why we don't see the graph there is because at negative 9 and negative 10, those y values are outside of our window. So we can do a couple things here. We can open up our windows, right? If we go into window, let's back up our x to negative 15, and then open up our y to positive 15. And that should show us more of the graph. Okay, so there's that one asymptote at negative 2. You can also see the other asymptote here right around negative 8. And then you can also see the other part of the graph. The y is positive on the other side. So let me add that to the sketch that I've got on the board, since we didn't originally see that. So this is what's happening out there. Okay. So now we've got all our critical values identified. We've got two roots at negative 1 and positive 1.5. We got an asymptote at -2 and an asymptote at -8. The problem is asking us where is y greater than 0. So here's one region, y greater than 0. Here's another region, and then here's a third one, y greater than 0. And if you're ever not sure, again, you can either zoom in on this section to double check that, or you can look in the table to make sure that those y values are positive out here, out past positive 1.5. Yeah, we've got all positive y values out here, and then we've got a couple negative y values in this region, right? That's this little bend in the curve right there. Okay, so now, if we want to answer the question, where is y greater than 0? So here's one region out here, x less than -8. Or this region in here, this is x less than -1, but greater than -2. And then our third region is x greater than positive 1.5, and there's the answer for number 4. Okay, we got 2 more to look at here. We're going to go over problems 6 and 8 before we finish up. And then I'll save the second half of this section for another assignment. Let's see here. All right, problem 6. What do we start with? X squared plus 2x plus 5 on top. X squared minus 3x minus 7 on the bottom. And here we want to know where is y greater than 0. Okay. So the roots is where the numerator is 0, and the asymptotes is where the denominator is equal to 0. Equal to 0 there. Okay. So let's look at the graph, and I'll draw a sketch and show you what the graph looks like on the calculator as well. So, x squared plus 2x plus 5 on top, x squared minus 3x minus 7 on the bottom. And I'll go back to the standard window. Okay. Looks like we've got 2 asymptotes. There's one here, and there's one out here. And the graph is kind of doing that. And then this. And then this as well. Okay, so to identify any roots and asymptotes, we want to run these quadratic equations through our quadratic formula. I'll do the asymptotes first. Let's see here, 1, -3, -7, and that gives us x is approximately 4.541 or -1.541. So this is 4.541 and this is -1.541. Now, let's run this equation through the quadratic, 1, 2, and 5, and what we get here is that x is -1 plus or minus 2i. Well, in case you didn't notice, there's no roots on this graph. Okay? So, let's see, I didn't show you the graph on the calculator here. But there it is. That's what it looks like. And you can see pretty clearly there's no roots on there. Okay? That's because the x-axis is all real numbers. There's no complex numbers on the x-axis or on the y-axis. These are all real number values. And so this value for what makes the numerator equal to 0, where the roots are, those come out as complex values. And so we're not going to see them on this regular graph. I've got a separate video that kind of talks about this a little bit, and I made it separate because it kind of goes beyond the scope of what we're talking about in this class, but it is pretty interesting. Okay. Okay? So if you're interested in that, you can take a look at that separate video. For our purposes, we just don't worry about this. There are no real roots. We're not going to see it on the graph. Now, I shouldn't cross this out because those are still valid roots, okay? And if you are working with something that involves complex numbers, then there's nothing wrong with these roots. It's just we don't see them on the graph. So as a result, our answer for where is y greater than 0 is just going to be these two regions here. X greater than 4.541 or x less than negative 1.541. And that's it for problem 6. All right, let's look at one more here. So, problem 8. What do we get here? X cubed plus 9 on top. And x squared plus x plus 1 on the bottom. And this one, again, we want to know where is the y positive. Okay, so x cubed plus 9 equals 0. Or x squared plus x plus 1 equals 0. These are going to be our critical values. That's where we're going to see the roots and asymptotes. Let's take a look at the graph first. X to the third plus 9 on top. X squared plus x plus 1 on the bottom. And let's see what we get here. Looks something like this. Now it almost looks like there's an asymptote there. Okay? This will tell us, solving this equation will tell us whether or not there actually is an asymptote there. So let me show you what the graph looks like first on the calculator. There it is. And then actually while I'm here, let me just expand our y values. Open up our window. Make our y maximum 15, and then if we go back and look at that graph again, there's the top. There's no asymptote there, okay? And so when I go back to the board, I'm going to improve our sketch here by including that little top piece right there, okay? Why is there no asymptote? Well, it's similar to what we saw in that previous problem. If you take this quadratic equation here, where a is 1, b is 1, and c is 1, again, you get complex values, negative 1/2 plus or minus 0.866i. And so that's why we don't see any asymptotes on the graph. It's because the asymptotes are actually complex values. This one over here, this one's a little bit tricky. One thing you can do is you can solve this, right? It's not quadratic, so we can't use the quadratic equation. We can take the cube root on both sides. And so if we do the cube root, so let me show you where this is here in the calculator. If you have the math button, let's see, come on, let's get some focus here. There's the math button. Hit the math button, and then you can see choice number 4 is find the cube root. Type in your negative 9. And there it is, about negative 2.08. And that corresponds to what we see on the graph, negative 2.08. Now, if you get something that doesn't correspond to what you see on the graph, then you've either got a mistake in your graph or a mistake in your solution here. The other thing that you can do to solve for that, let's see here, is to use that root finder, right? Where you hit second trace. Choice number 2 is find the 0. And then we've got to go down, set a left bound, set a right bound, and we're just going to come out with the same answer there. Oh, one more time. Hit enter one more time, and there it is, negative 2.08. Now the calculator won't do that for asymptotes, okay? So you can do that to find roots, but the calculator won't find the asymptotes for you. You've got to solve this equation to know where those values are. So this is it. This is the only critical value in problem 8. And so we want to know where y is greater than 0. Well, that's just going to be x greater than negative 2.08. And that's it for that one. Okay, so for the first half of this section, I just want you to do problems 1, 3, 5, and 7. They're very much like the problems I did on the board. Pay attention to where the roots are, where the asymptotes are, and make sure what you're calculating here matches up with what you see on the graph. Okay? And then when we come back and do the second part of this section 2.4, we'll look at some more problems. As always, if you have any questions, please let me know. Thanks.